As I've stated before, there are many, many trends within the periodic table that we can use to actually predict the properties of any element on the periodic table based solely on its location. This is one of the powerful things of the periodic table, that the organization of it is spectacular and has so many different trends and patterns hidden within it if we know how to look at it. So to get a little more complicated beyond the metals, nonmetals, and nonmetals, remember hydrogen, although it's on the left side of the periodic table, does belong on the right side in that it is a nonmetal. It's the only exception within that particular trend. What we're going to talk about next is a little bit going towards the atomic radius. So first things first, the nuclear charge, of course, is the charge created by the nucleus. So this is the attraction of the neutrons, the protons to the electrons, okay? I don't know why I said neutrons, excuse me. The charge of the protons and their attraction to the electrons whizzing around outside in the energy levels outside of the nucleus. The shielding refers to the inner energy levels. Remember that they are not very important. We don't really ever talk about the inner energy levels because, again, they are shielded. They are not really exposed to the exterior. Therefore, they are not responsible or in any way involved in bonding with other elements or other atoms. So they're shielded. And again, this is just some vocabulary. The main group elements, if I was going to very quickly draw a very small periodic table, the main group elements are these right here, not those and not those. It's going to be, again, just to kind of highlight what I'm talking about, is this right here, group 1 and 2, and group 3 through 8. Those are our main group elements. We're going to talk about them mostly. These transition metals and these inner transition metals, the actinide and lanthanide series, really kind of follow their own rules. They're called transition metals because they do not follow strict patterns that we're about to learn. So when we talk about a lot of these periodic trends, we're really talking about the S and P block, or the group 1 and 2, and then the groups 3 through 8 on the other side of the periodic table. Okay, so the first one we're going to talk about is atomic radius. You guys all know what a radius is. It's basically half the diameter, the center to the outer part of a sphere. We use this in order to measure the size of a particular atom. We could say diameter, which I think would make a lot more sense, but we use a radius from the nucleus to the outermost energy level. It's, again, another way of saying the size of an atom. Okay? So again, we can already predict how big an atom is based on the periodic table if we know where it's located based on this particular thing. So the periodic trends, meaning trends across the period, pick any period 1 through 7, and as we go left to right, they are going to increase to the right. Okay, the atomic, oh my gosh, got that backwards. Sorry guys, I don't know what I'm thinking. The atomic radius is going to increase as you go to the left. Now that sounds kind of weird because you're adding more protons and the atoms are getting bigger and bigger and bigger as you go to the right of the periodic table, but you're also adding more electrons. Because you're adding more positive protons and more negative electrons, what happens as you go to the right of the periodic table is they actually get smaller. It's more, there's more attraction, there's more, it's being squeezed into a smaller space. Not by a lot, but by a little bit, right? As you go to the left on the periodic table, there is more, or excuse me, less protons, less electrons. Therefore, the atom is more relaxed. It's more spread out. It's not being pulled in so tightly. So that's why the atomic radius is actually a bigger atom as you go to the left side of the table and smaller atom as you go to the right. It's kind of counterintuitive. It's backwards of what you might expect. But again, it has to do with the attraction of the nucleus to all the electrons out here. More protons, more electrons, it's going to squeeze it in. Less is actually going to relax it a little bit. Now the group trends, which again are your columns, going down any group, pick any group of the main group elements, and as you go down, not surprisingly, they do get bigger. And that's because you're adding more and more energy levels. Remember, every element on the second period is going to have 2 energy levels. Every element on the fourth energy level is going to have 4. So you're going to add 1, 2, 3, 4 all the way down to 7 energy levels. So naturally, not too surprisingly, they do get bigger as you move down the periodic table. Okay, so what we need to do now is arrange these in order of increasing size. Now what I'm going to do is I'm going to project a periodic table on here, so that way we can kind of see it and go through it together, if I can. All right, so the first thing is we have 10, SN is 10. It's located right here. And we have SR, which is strontium, which is located right there. Now remember, the trend goes to the left and down. Francium is the largest atom there is. Okay, this is the biggest atom. Again, even though we can never find it because it's too highly reactive, being an alkali earth metal, it would be and is the largest atom. So between strontium and tin, clearly, again, the trend going this way means that strontium must be larger. So it already is in the correct order, SN, and then strontium from increasing size, from smallest to biggest, okay? All right, the next one we're gonna have is sodium. Sodium's located right here, and rubidium, which is located right here. Again, the trend vertically is increasing going down, so clearly that is also in the right order, ironically. Sodium is smaller and rubidium being larger, okay? The next one we have is a little more difficult because we have 3 elements. We're gonna have astatine, which is AS right here. We're gonna have nitrogen there, and fluorine, which is right here. Okay, so we have kind of a weird triangle. So in increasing size, we would have the smallest would be furthest away, because remember the trend goes this direction, down and to the left. So fluorine is the farthest from francium, is the easiest way to do this. So fluorine would be the smallest. The next smallest would be nitrogen, because it has the same number of energy levels, but it's just a little more relaxed, so it's just a little bit bigger. And then finally, astatine would be larger because it has 2 more energy levels than both nitrogen and fluorine. So it's going to be significantly bigger than both fluorine and nitrogen. Okay, let me clear this out real quick so I could then move the periodic table so we can see the other side. All right, moving this over here. Sorry, that's a little bit funny looking, but oh well. Oops. Okay, so here we have beryllium. Beryllium, again, is located right there. Magnesium is directly below it there, and calcium, which is below that. So this is an easy one. Remember, the trend goes to the left, gets bigger, and going down gets bigger. So not surprisingly, beryllium, actually, dang it, it's already in the right order. Beryllium, magnesium, and calcium are in the correct order from increasing atomic radius. Again, because it'd be going this way. Remember, francium, this is what you want to remember, francium is the largest of them, of all the elements. Okay, the last one we have is tellurium, iodine, and xenon. Tellurium, iodine, and xenon. Again, knowing the trend goes to the left and down, but they're all in the same period, so what difference does it make? The smallest would be xenon. The next largest would be iodine. And the largest of those 3 would be tellurium. There we go. Again, it's a very simple thing to do. It's all about looking at the relationship of their location on the periodic table and seeing which one's farthest to the left and which one is the lowest. Again, basically the trend works in a diagonal pattern towards francium. Francium, again, being the largest of all of them. Another summary I could show you guys, again, in your notes is you are shown this little pattern here. Again, this is just the major group, main group elements. Right there should be the transition metals, but we excluded those because, again, they're quite different. So here is your helium, neon, all the way over to cesium. Again, francium would be right here, but again, we don't ever see francium. So again, notice the pattern goes that direction on the periodic table.